Okay, now we're going to be talking about structures, species that have formal charge, and how can we do the bookkeeping of electrons. So if you guys remember, again, this is methane, and we have for bonds. We define formal charge, and we're going to say formal charge of that carbon by the number of valence electrons, and we know the valence electrons for the carbon is 4, and here we're going to subtract the number of electrons that are being shared, so in bonds, so 2, 4, 6, 8, divided by 2, and here we have 0 lone pairs. And so formal charge here is 4 minus 4 is 0. But now, if you have, say, only that, and there will be, the formal charge here is a plus, because you will have, in this structure, if you calculate, the formal charge here is 4 minus, and then we see the number of electrons in bond is 2, 4, 6, divided by 2. We don't have lone pairs, and that is important. So this is the number of unshared electrons. So in the lone pairs, and these are the electrons that are shared. So being a part of bonds. So we don't have lone pairs, so here the formal charge would be plus 1. So if we see then a carbon that is missing one bond, then will be formal positive charge. So now, and that would be important enough for the line structure. Let's do this now. Now I have a lone pair. What is the formal charge of the carbon in this case? Okay, and this little c means the carbon, because we're going to do formal charge in other atoms as well later. So the number of valence electrons is 4, minus here the number of electrons that are being shared, so in bonds, 2, 4, 6, divided by 2. And now I have these 2 electrons that are, remember, unshared, part of the lone pair, so I have 2 here. And so now we have this is 3, and 2, that's 5, so for minus 5, that's a negative 1 formal charge. So this is what we call a carbanion. And this here is called a carbocation. So species that have charge. Okay, and so what I'm going to do now is draw a structure that contains a formal charges on carbon, and see if we can tell the number of hydrogens that are attached. So keeping these patterns in mind, if we have this right here, notice that for the pattern of a carbocation, I have 3 bonds in that formal charge. That means there is no hydrogen here, because we have, this is incomplete. It only has 6 electrons, so it's similar to this pattern. Now if I have this one here, what that positive charge means is that we have only 3 bonds and we're missing electrons. So we have, again, this pattern. If we have 3 bonds and we're missing an electron, instead of being a CH2, which is what you will have normally, CH2, CH3, CH3. Now this one, say, is missing electrons, is missing 1 bond. So here you will say we have only 1 hydrogen, right? So using the formal charges. And finally, if you had, say, this formal charge here. Now notice that if you count, notice this pattern, 3 bonds, right, in this formal charge. What that means is at the end, instead of having a CH3, this at the end is a CH2 and this. So CH2, CH2, and CH3. So bottom line, we need to keep in mind the formal charges to be able to tell how many hydrogens do we have in any of the carbons. So formal charge is another important concept when we're doing analyzing and reading our line structures.